trusting people. A random sample of 190 people from a younger age group shows that 95 people said that they trust people. In comparison, 78 said they trust people. This is taken from a random sample of 140 people from an older age group. My question is there enough evidence to show that older age group tends to trust people? That means the older age group has a higher proportion. So that means young is less than old. So for the first sample, P1 had that is x1 over n1, 95 out of 190. And then for the second sample, the older group, x2 over n2, that is 78 over 140. And then the pool proportion is you add the 2x and then you add the 2n. Okay, let's show the H0 and HA. So the HA is young less than old, right? So in my HA, I have P1 less than P2. And then my H0, the problem didn't give me any sign. I will just take the opposite. P1 greater than or equal to P2. Okay, so since this is a less than, P1 less than P2, then this is a left-sided test. Left-sided test means when you graph the p-value and the z, the p-value is on the left-hand side of the curve. All right, and then the next step, you will have to move on to your calculator. So you hit stat, you hit the stat key, and then you go to test, and then you find two prop z tests. That means two proportion z tests. You pick that, and then that brings you to the second menu. So you have x1 n1 95 out of 190, x2 n2 78 out of 140, and then you pick the inequality size. I pick the one in the middle, less than. That means P1 less than P2. This is a left-sided test, and then you hit calculate. So when you hit calculate, you have the z and the p. So the z, let me give you the formula. So that is z equals to P1 hat minus P2 hat, and then divided by the pool proportion. That is P hat 1 minus that, and then multiply 1 divided by n1 plus 1 divided by n2. And then the calculator said z is negative 1.027, negative 1.027. I usually use 3 decimal places, and then the p-value is pretty big, so the p-value is equals to 0.1521, so that is greater than our significance level 10%. Greater than 10%, so this is a fail to reject H0. And then for other than calculate, so you click draw. If you click draw, that brings you to the graph. So I already said that this is a left-sided test, and then you have a region on the left. That region is the p-value, and then the cutoff is where the z is. So this one, if you want to find the p-value manually, then you will have to use the normal CDF. You study that in normal distribution, so you will have to go to second, and then you hit the vars key, and then you select normal CDF, second vars, and then you select normal CDF, and then the lower limit is negative infinity, the upper limit is negative 1.0273, and then the mu is 0, standard deviation is 1, and then once you hit paste and calculate, and you will get the exact p-value. But you already have that. The test already reports the p-value, so why using the normal CDF command, right? And then let's write the conclusion. So the conclusion is, so since p-value is greater than alpha, then we fail to reject H0, fail to reject H0. So that means no evidence to show HA is true, so no evidence to prove HA is true. That means we are not able to get to HA. We are still stuck at H0, and then H0 remains suspicious. So what does that mean? We do not have evidence to show that older age group tends to trust people. So we don't have evidence to show, so no evidence to show that older age group tends to trust people. And then this is the end of the hypothesis test. When you do works online, they will ask you to do this. They will ask you to say, hey, P1 hat minus P2 hat. Look at the screenshot right over here. P1 hat minus P2 hat follows normal distribution. What does that mean? That P1 hat minus P2 hat represent the sampling distribution, follows normal distribution. They want you to just input a word capital N, and then with mean P1 minus P2, that is equals to 0. This is always equals to 0 because in your null hypothesis, you assume P1 is equals to P2. And then what about the square root term? The square root term is the same thing as the denominator in the Z formula, right? So where do you find the P hat? You find the P hat right over here, right? So this is the P hat. So the P hat, let's use 3 decimal places. P hat is 0.524, and then you have your N1 equals to 190, and then your N2 is equals to 140. So plug it in, take the square root, that gives you the answer. And yes, you do have to round. How many decimal places? Just follow the direction. Okay, so this is the end of the hypothesis test. Let's move on to the confidence interval. So let me switch to a different color in the meantime. So confidence interval, we have a 10% alpha, right? So we have a 10% alpha. That means we are conducting a 90% confidence interval. Okay, so 90% confidence interval, go back to your calculator, you go to stat, and then you go to test. So you hit the stat key, and then you hit the right arrow to test, and then you select a 2 proportion Z interval. So once you click the 2 proportion Z interval, the numbers you input will roll over. Just pay attention to the confidence level, the C level. Make sure the C level is right. So the C level, this is a 90%. And then once you hit calculate, you will get the confidence interval. And then what's the formula? The formula is you have a point estimate, which is P1 hat minus P2 hat, and then plus or minus margin of error. Margin of error is the product of Z alpha divided by 2, and then you multiply a square root term. The square root term is P1 hat 1 minus P1, and then divided by N1. You do the same thing for P2. So P2 1 minus P2 divided by N2, and then you take the number straight from your calculator. That is negative 0.1484, and then positive 0.03412. This one, if you want to put that in percentage, all you have to do is you multiply 100 and then put the percentage. So this is a 3.4%, right? And then this is a negative 14.8%. So did you see that I just used the p-value to fail to reject H0? So how do you verify that that conclusion is true? So all you have to do is you draw a verification, right? I'm trying to verify the conclusion I drew. So I'm going to recall H0. So my H0, what is my H0? My H0 is P1 hat greater than or equal to P2 hat. So P1 greater than or equal to P2. So that means P1 minus P2 is greater than or equal to 0. So what's the purpose of confidence interval? You are saying that the truth is between negative 14 and positive 3, right? Is 0 between negative 14 and 3? Yes. How about greater than? Greater than means positive value. Do we have positive values between negative 14 and 3? Also a yes. That means the entire H0 is inside the confidence interval. We say this is inside the confidence interval. So since that is inside the confidence interval, H0 can be the truth, right? That maybe that is true. So H0 can be true. Then you fail to reject H0. Reject H0. So we just fail to reject H0 using a confidence interval. There are two ways to do it. Either you use a p-value, which is what everybody does, or you use a confidence interval. This is called verify. And then how do you explain the confidence interval? How do you explain? So let's explain the confidence interval. How do you explain? Explain those two numbers. The correct language is we are 90% confident. So we are 90% confident that the difference proportion of trusting people between the two age group falls between, let's just do negative 14.8%, 14.8% and positive 3.4%. That's it. That's how you explain. Let me tell you one more thing. This kind of explanation makes no sense. I'm not saying the explanation is wrong. The sentence is perfectly right. The biggest problem happens right over here. The biggest problem happens in the negative and positive. So let's say I have two numbers. So let's say I give you two numbers, 10 and 7. Which number is bigger? You subtract them, right? 10 minus 7 is equals to 3, so that is greater than 0. So I know 10 is greater than 7, right? So if I compare 7 and 10, 7 minus 10 is negative 3, then this is less than 0. That means 7 is less than 10. If you compare 7 and 7, you subtract them, that is equals to 0, then 7 is equals to 7. That means every time you compare two numbers, the result is either greater than 0, less than 0, or equal to 0. That means it's either one bigger than the other, one less than the other, or they are equal. If you if you have negative and positive, that means let's make the number simple. Let's say I am asking you to guess. I have two numbers in my mind. I am asking you to take a guess. And my hint is the difference is between negative 5 and positive 8. Is this hint helpful? The answer is no, because if the difference is equals to 0, that means those two numbers are equal. If the difference is negative, that means one is less than the other. If the difference is positive, that means one is greater than the other. If I give you a negative and a positive, that means I am telling you nothing. The hint is there, but it's not helpful at all. That another way to saying this kind of statement is I am confident that the average, people take an exam, right? The average is between 0% and 100%. Is this statement helpful? The answer is no. Of course, when you calculate the average of people's exam score, it's always between 0 and 100%. If you say 0 and 100, that means you include all the possibilities. So this kind of statement is not helpful. So that's what happened when you have a negative and positive in a confidence interval. And one more thing, the negative and positive, it doesn't matter how you state the H naught, P1 greater than or equal to minus P2. So P1 minus P2 greater than or equal to 0, equal to 0, or less than or equal to 0. I don't care which sign you use. It's always inside. So when you have a negative and positive in a confidence interval, you know that this is guaranteed a fail to reject. All right, so that is the end of the confidence interval part and also the end of this problem. If you like it, give me a like, share, and subscribe. And I will see you all in the next one. Signing out.